You might have wondered at one point in your math studies, what is the reason behind the weird rules of fraction division? In this video, I'll try to shed some light on it. Here's a fraction division problem that I'm going to use to illustrate my points, 7 over 4 divided by 1 over 2. And the rules for this fraction division were typically worded in the neighborhood of step 1, flip the second fraction upside down. The second fraction is 1 over 2 and rewrite it as 2 over 1. That's step 1. Step 2, change the division into a multiplication. So rewrite this original division problem, replace the division symbol with a multiplication symbol there. In other words, take the original problem, a division problem, rewrite it as a multiplication, pretend that this multiplication is the same as the original division problem, and solve it from here on as a multiplication. In other words, 7 gets multiplied with the 2, and that's your new numerator, gets written, 14 gets written in the numerator position, and 4 gets multiplied with the 1, and gets written down into the denominator position as 4. And that's your final answer, 14 over 4, in an improper fraction format. Of course, this can be converted to a mixed number, so 4 goes into 14 3 times, so there's the 3 with a remainder of 2, and that's 2 over 4, and the 2 over 4 gets reduced to lowest terms, 1 over 2, so there, 3 and 1 over 2, 3.5 is the final answer. So, it doesn't happen in math very often that an original problem is turned into a different problem and that's solved, and we walk away happily that this is still the answer to the original problem. So, my first reason I want to illustrate with these coins. We have here $quarter coins. Each of them is worth 25 cents. So in a total we have 7 of these quarters, which is the representation that's written in a fraction format like this, 7 over 4. And of course, out of these quarters, because they are quarters, so 4 of them will make a whole dollar. So that's $1.75, or 1 3/4 in mixed numbers, and 7 over 4 is an improper fraction again. It can be written as 1 3/4, but this is how fraction division rules can be applied to common fractions and improper fractions, not to mixed numbers. So instead of 1 3/4, we're going to go with 7/4. So this fraction division problem as a division is asking how many times, and at this point I want to pause here because I said the word times, and I want to put it here. And we're going to use it later because even though this is a division problem, I just said the word times. So how many times does this $half amount go into, because this is division, go into 7/4? So this is how it looks like with these coins. Let me just show you. How many $half amounts, how many times $half goes into 7/4? So let's make $half amounts here. So that's $half there, 2 quarters, there's 50 cents there. There is another 50 cents, $half there. So that's 2 groups, or 2 times so far. There's a third one, so we're on the right track there. 3, so that's 3 is represented by these 3 $half amounts, and there's a remainder of 1. Now this remainder of 1 is not just 1, it's and it's not 1 over 2. This means that in a group where 2 coins make a whole group set of $half, this is half of this group that consists of 2. So this is half of 2. This is not $half, this is half of $half. We are making $half groups. So I hope this makes sense. This way that this is half of $half, so that's why this is there is a half there. So we have 3 groups of $half and then a group of $half. Alright, so this meaning of this 3.5 is a group number, or number of groups. I'm going to write it here. Number of groups. And this half is a dollar amount. So I'm going to put a dollar symbol there. And 7 over 4 is also a dollar amount. So dollars were divided by dollars, and we get different groups of these these $half groups. So 3.5 groups, namely. So that's the context for or the meaning behind the original division problem. So why the rules are written this way is reason number one. I'm going to write it here. Because of reality. The nature of reality, the nature of dividing things is that whatever rules you want to invent and impose on the rest of the society or population, you want to make sure that it actually coincides with reality or reflects reality consistently and repeatedly. And every time you do a division into smaller and smaller groups, this is how division works, not just with these coins. So the rules that were invented here for a reason to coincide with reality. So that's part of the answer. That's explanation number one, or take one, or approach one. Okay, I have a second approach here, and it doesn't need coins, so I'm going to get rid of those. Reason number two behind the weird rules of fraction division is logic. And this was already kind of based on logic to some degree, but this is the logic of multiplication and division. And the two relate to each other. That's why I wrote the word times here. So the original meaning of division is how many times half goes into 7/4. And I want to show you something here about how multiplication and division relate. I'm just going to jog your memory a little because it's not going to be new. And I'm going to do it with whole numbers. And then I'm going to show you how this relates to fractions. So for this, very simply, I'm just going to pick easy whole numbers such as 15 divided by 3 equals 5. That's a division statement. And there is a similar division statement that mirrors this. 15 divided by 5 equals 3. So that's, you can see that these two are interchangeable. The 3 and the 5 can trade places, and it's not the same thing, but both are in the same division fact family. And we have two multiplications, of course, that correspond to these. We have 3 times 5 equals 15. You can take the result of division, the quotient, and multiply it back with the divisor. Multiply these two together to get the original dividend that we started with. And of course it works that way as well. There. So we have two multiplication sentences and two division sentences, and this is one fact family here that belongs together. Now, so if this works with whole numbers, that means that whatever rules are invented for fraction division, the rules must work with fraction division the same way. That is, if you take the final answer and multiply it with the divisor, you must get the dividend back. Let's try it. I'm going to use this pen here, and instead of the mixed number, of course, I'm going to use the improper fraction version, so that is also the final answer. So I'm going to take 14/4, and so these two need to be multiplied. So get half, multiply it with half, and we must get 7/4 after this. Let's see. 14 times 1 is 14. 4 times 2 is 8. 14/8, both of them are even numbers and can be reduced by a factor of 2. If we divide 14 by 2, we are going to get 7, and if we divide 8 by 2, we are going to get 4. So indeed, 7/4 is the dividend that we started with in the first place. So what we can see from this is that this is the correct answer, or in mixed number format, either which way. And whatever magic was done in the box here, this flipping over and turning a division into a multiplication is a valid thing, because it not only reflects reality with coins, it also works with the inherent logic of multiplication and division, which works with whole numbers and decimals. So it must work the same way with fractions, and it does. These whole numbers can also be turned into fractions very easily. Every whole number is a fraction of itself, or over 1. 15/1 divided by 3/1 must equal 5/1. Let's do the math. 15 over 1 times 1 over 3, because we're flipping the second number upside down, and that becomes a multiplication. 15 times 1 is 15, and 1 times 3 is 3. 3 goes into 15 5 times with no remainder. So it's a 5 over 1. Or we can reduce 15 by a factor of 3, and 3 is reduced by a factor of 3. So 15 divided by 3 is 5, and 3 divided by 3 is 1. So it works with both of these approaches. So these are two answers why the weird rules that we turn division into a multiplication is there. It reflects reality, and it reflects the inherent logic of how multiplication and division work with each other.